All right, welcome to this lesson here where we're going to be taking a look at how we can join like terms in a linear equation. That's kind of our main part of it. And we're going to start off with what are like terms, how do we join them, and then how do we solve for an equation from that problem there. So what you're going to see on screen here is we have a selection of items, ones that you might get at a grocery store. And these items here are kind of related to fruit. We have apples, oranges, we have apple juice, orange juice, and we also have applesauce on there. Now, I'd like you to kind of think about what types of things would you combine if you were to do this at a checkout, okay, at a grocery store. Well, we would probably want to combine our like items, right? We're going to combine how many apples do we have, how many oranges do we have, and so on and so forth. Now, I'm going to kind of lead that one more step further there, and we're going to look at these here and compare them to variables. So like an apple, we could say is X. A orange, we could say is Y. Then based on that, we would think that our orange juice, okay, I'm going to assume kind of orange juice, at least at this part here, would be then considered, okay, y squared, right? It's like oranges, but it's a little bit different. Okay, it's not the same thing, but it is the same root, and so we're going to call that y squared. Apple juice would be x squared. Applesauce could then be x cubed. Okay, there we go. So we have a bunch of different ways of describing this here. We have our root, okay, x being our root, and then anything made of apples could be like x squared or x cubed. We have oranges being y, and then anything made out of oranges would be y squared, y cubed, and so on and so forth. Now, terms are considered like when they are the same, okay? And we can collect all of our apples together and all of our oranges together and then all of our apple juices together and such, and keep. And that is how we would join them. We won't join apples and oranges together. We would only join our apples together. So if we go back to our big collection here, okay, collecting them together, we might collect all of our apples. There we go. Okay, they're all together. We can collect all of our oranges. We got 3 of them. Collect all of our applesauces. There we go. We got 2. All of our orange juices and all of our apple juices. There we go. So we've got 4 x's, 3 y's, 2 x cubes, right? We're collecting them together, and that coefficient becomes how many of them we have. Okay, so it's one way to think about things. Okay, it's a way to kind of think about how things are grouped together, and it's all based on like terms. Now let's take a look at an algebraic expression and how we would combine like terms here. So let's combine all of our like terms in x plus 5 plus 2x plus 7. All right, so what we have here is we have some x terms that are like x and 2x. When we combine them together, we'll get 3x. We have some numbers, or what we call constants, that are there, and we can combine them together to get 12. So this expression is going to be simplified to 3x plus 12. There we go. It's a little bit more simplified because we're combining our like terms together. Let's take a look at this one. Okay, what you might want to do is pause here and then start it up again once you have an answer, and we'll see what that answer looks like. All right, let's take a look at the answer. What we have is we have some x values, okay, 4x and 2x, which become 6x, and we have some y values, 5y and 3y, which combine to be 8y. Now, those are not like terms, so we can't put them together to become 14 something. Okay, no, they are different, so we have to keep it at 6x and 8y. And then we're adding. That's all it is. It's just showing that it's adding together, and that simplifies our expression. Here's another one. Okay, combine these like terms, unpause the video when you're finished, and we'll see what kind of answer you got. All right, welcome back here. Let's take a look. We have some numbers, 7 and negative 8. Be careful about the negatives there. When we put these together, we're going to get negative 1. We also have negative 4 and positive 7. Again, careful about the negatives, but we'll combine these together to get positive 3. And then our final answer could look like 3x minus 1 or negative 1 plus 3, as long as the negative is in front of the 1 and the 3x is on its own. Okay, so we got to make sure that we have the two pieces have the right sign in front. Okay, but we can mix around where those pieces are. Here's another one. Okay, let's try this one. Pause the video, start when you get your answer. Okay, let's take a look at our answer here. We have x terms, 5x and negative 3x, which becomes positive 2x. We have 2x squared and negative 2x squared, which becomes 0x squared or nothing. And so our final answer simplifies to 2x. And that's it. There's our answer. Okay, so we can do that. Now, let's bring this into a linear equation because now we have the equal sign in there. So it's no longer just an expression, it's an equation. And let's combine this and solve for x. So give this one a shot. Unpause when you have your answer. Okay, let's take a look. What our answer is going to be, well, first thing we want to do is we always want to combine our like terms. 3x and 2x becomes 5x. So we can simplify this now to 5x equals 45. To solve this, we're going to divide both sides by 5, okay? And we get an answer of 9. Okay, so x has to be 9. All right, give this one a shot. What do you get as an answer? Okay, let's take a look at the answer here. We have y and negative 2y. So what's going to happen is these are going to simplify to be negative y. And so negative y is equal to 13. Well, we have to remember that we always want to get a positive y value. So we have to get rid of that negative y or that negative 1 in front of the y. Two different ways we could do it. We could either multiply or divide by a negative 1. When we do that, though, it's going to change the sign of each piece. So the y, negative y becomes positive y, and the 13 becomes negative 13. And so our answer is going to be negative 13, or y is equal to negative 13. All right, let's try another one here. Okay, give this one a shot. Come back when you have your answer. Okay, with this one here, we're going to combine together our c values first. So on top, we have 4c as our answer there on top. And so we have 4c over 8 is equal to negative 4. Now there is a couple ways that we can solve this here. One thing we have to realize is that the c can be kind of outside the fraction. Could be in the fraction, but it could also be outside the fraction. And we have 4 over 8, which can simplify down to 1/2. Okay, so 1/2 c equals to negative 4. And then we just multiply both sides by 2. And that's going to give us a c value of negative 8. So far, so good. Kind of feeling good here. All right, let's try another one. Okay, pause the video. Come back when you have your answer. Okay, let's take a look at the answer here. We have 3g and 2g, which again, we can combine to become 5g. When we do this, we're going to get 5g is equal to 12. We're going to divide both sides by 5, and we're going to get that g is equal to 12 over 5, or 2 2/5. Now, if you put it into a decimal form, that's going to be 2.4, which works as well. Just fractions are a little bit nicer because they will never be repeating. They'll never, have to simplify or round the answer. So fractions are just a little bit nicer for the most part. All right, let's try this one here. Combine your like terms. What kind of answer do you get? Let's take a look. We have 2e and negative e. When we combine that together, we get left with a single e. That's it. Done. Now, this might seem a little bit weird because it says 6 equals e. Well, are we done? We are. That's it. That's all you need to do. So our e value is going to be 6. Thank you so much for watching this lesson. I hope that it's helped you out. All the best as you work through your questions, and have a wonderful rest of the day.